Hello everybody, welcome to the live session by Infinity Learn by Sri Chaitanya. I am Misbah, your maths educator, and we are over here with proofs of irrationality. In the previous session, we did concepts related to real numbers. We've learned how to find HCF, LCM and the relationship between HCF and LCM, and have done some questions on the basis of irrational numbers as well. In this class, we'll learn how to prove an irrational number to be an irrational number. Hello Akash, welcome to this session. So are you guys able to hear and see me properly? Let's wait for some more seconds, let other students join as well, and then we can start with the class. So basically in proofs of irrationality, only two things are there, three types of questions are asked. Hello Murli, welcome to this session. Hello Ayush, good evening, good afternoon. I mean that is evening only, good evening, welcome to this session. So let us wait for some more seconds and then we'll be starting with the class. We'll learn how to prove a number to be irrational. So three types of questions are there in it, not more than that. And after that, we'll be seeing some questions on the basis of irrational numbers. Hello Ayush, welcome to this session. Okay, so let's start with it guys. So the very first theorem you've got over here, let P be a prime number if P divides A square, then P divides A as well, where A is a positive integer. If P is a prime number, right? P is a prime number, and if P divides A square means P is a factor of A square, P is a divisor of A square, then P will be dividing A as well. But the thing is, P has to be a prime number. For example, you see over here that 3 divides 36. Yes or no? 36 is 6 square. 3 divides 36, 3 is a prime number and 36 is equal to 6 square over here. So 3 will divide 6 as well for sure. Yes or no? If 3 is dividing 6 square, then 3 will be dividing 6 as well. It means 3 is a factor of 6 as well. And the only thing which you have to keep in your mind is this has to be a prime number. Is it clear to everybody in this session? Just confirm that. It's a simple property which you must know, because using this property only we are going to do proofs of irrationality over here. I hope that is clear. For example, you take that anything you can take, it's all up to you. Suppose 5 divides 225, right? 5 divides 225. 225 is what? 15 square, and 5 is a prime number. Therefore, for sure 5 will divide 15 as well. It means 5 will be a factor of 15 as well. Simple property, yes Murli. It is a very simple property. Any doubt in that? The only thing which you have to keep in your mind is P is a prime number. P has to be a prime number, then only it will happen. I hope it is clear to you. Any doubt in this thing? For example, if it is not a prime number, it will not happen. For example, you see 4 divides 36, right? 4 is a factor of 36, right? 36 is what? 6 square. But does 4 divide 6 as well? Tell me. No. 4 is not a factor of 6. Yes or no? Because it is happening because 4 is not a prime number. 4 is a composite number. I hope it is clear that if 4 is a factor of 36 and 36 is 6 square, so you see 4 does not divide 6. It is not happening like this. This is not happening because 4 is a composite number. It's not a prime number. I hope it is clear to you. Okay. So on the basis of this property only we are going to prove irrationality. The proof of root 5 is an irrational number, right? So let's prove root 5 to be an irrational number. So let us take root 5 to be a rational number, right? So we'll do this proof using something called proof by contradiction. Proof by contradiction we'll be using over here. So it means we'll be doing it proof by contradiction. It means the opposite we will assume. We have to prove that root 5 is an irrational number. So we will assume that root 5 is a rational number, right? So if it can be assumed to be a rational number, so therefore root 5 can be written as P by Q, yes or no? Because if you are assuming root 5 to be a rational number, you can write root 5 to be equal to P by Q, where P and Q are co-primes. P and Q are co-primes and q is not equal to 0, right? If you can assume root 5 to be a rational number, then root 5 can be written as a ratio of two co-prime integers where denominator is not equal to 0. I hope it is clear to everybody in this session. Don't forget that they are co-primes. Co-prime means there is no common factor between p and q except 1. Or you can say that HCF of p and q is 1. The highest common factor of p and q is 1. There is no common factor between p and q except 1. I hope it is clear to you. Now let's square on both the sides over here, guys. Can we square on both the sides? So we can get root 5 square, that is equal to p square q square. So from here root 5 square is nothing but 5. So from here this is 5 is equal to p square upon q square. So I can write 5q square is equal to p square over here. I can do something like this. So from here what does it mean? What can I write over here if I am writing 5q square is equal to p square? I can write over here that 5 divides p square or not. I can write 5 divides p square, right? 5 divides p square means 5 is a factor of p square. 5 is a factor of p square. Exactly, Ayush. So if 5 is a factor of p square, so we can say that 5 divides p as well. Yes or no? We have studied this property in the previous slide, this theorem in the previous slide, that if 5 divides p square, 5 will divide p as well. Dividing means 5 is a factor of p square. Why you can say that 5 is a factor of p square? It is as simple as that. See, because over here what can I do? I can write p square upon 5 is equal to q square or not? Tell me. It means if you are dividing p square by 5, you are getting an integer square or not? Tell me. So what does it mean? Can we not say that 5 is a factor of p square? That we write like this, 5 divides p square. And if 5 is dividing p square, so because 5 is a prime number, we have already 5 is a prime number. So therefore 5 will divide p as well, right? And if 5 is dividing p, what does it mean? 5 is dividing p, it means p divided by 5 can be written in the form of some integer c. Can we do that? Because 5 is a factor of p as well. So we can write p divided by 5 is equal to c, some integer over here. So can I not say over here that p is equal to 5c can be written for some integer c? Is this clear to everybody? Hi Dinesh, welcome to this session. So therefore we can write p is equal to 5c where c is an integer. C is an integer. I hope this is clear to everybody in this session. So we can write p is equal to 5c where c is an integer, right? Now if we can write p is equal to 5c over here, if I can write p is equal to 5c, can I put it over here? In place of p we can write 5c over here. So what will I get? 5q square is equal to 5c the whole square over here. So this is nothing but 25c square. So from here can I write q square is equal to 5c square? Q square is equal to 5c square I can write. So what does it mean? If you can write q square is equal to 5c square, can I not say over here that 5 divides q square? 5 divides q square over here. So I can say that 5 divides q as well. Is this clear to every student in this session? Okay, Dinesh. Is it clear, Murli, Ayush, Dinesh? Any doubt in this session that in this concept over here, we have proved that 5 divides p as well as 5 divides q as well. What does it mean? That 5 is a common factor of p and q. So it contradicts our assumption. Basically, we assumed in the very first step that p and q are co-prime numbers. That is, they don't have any common factor except 1. But we have proved over here that 5 is also a common factor of p and q, right? We have proved that. Hello Shashi, welcome to this session. So what does it mean? We have basically proved that p and q are not co-primes. So isn't it a contradiction? Contradiction means what we were saying earlier, something is coming opposite of that, right? It is proving that thing to be false, to be wrong. So basically our assumption of taking root 5 upon PQ we have done, which we have done earlier, and we have assumed that P and Q are co-primes. This is contradicting the fact that P and Q are co-primes. Then what we can say? That our assumption was wrong in the first place. That's how you do proof by contradiction. We will say that our assumption was wrong in the first place. Hence we can say that root 5 is an irrational number. Then we can say that root 5 is an irrational number. It is not rational. Is it clear to everybody? Murli, Ayush, Dinesh, Shashi, is it clear to everybody in this session? So proof by contradiction you have to understand, and obviously you have to practice questions. You don't have to mug it up. Everything is logical over here. What you have to think, I mean obviously something or the other you have to remember. The first thing which you have to remember is to take root 5 to be a rational number in the first place. You know that it is an irrational number, but you have to assume its opposite. So you will assume that root 5 is a rational number in the first place. So root 5 can be written as a ratio of two integers. Root 5 is equal to P by Q, where P and Q are co-primes if you have written, so that is okay, and Q is not equal to 0. Now what I can do, I can square on both these sides over here. I am repeating it once again, guys, you will understand. I can square on both these sides over here. So what will I get? Square root of 5, the whole square is 5 only. So that is P square upon Q square. So basically see, P is an integer, Q is an integer. So if you can write it like this, see this thing, I can write like this as well or not, tell me. I can take 5 over here and Q over there. So I can write Q square is equal to P square upon 5. What does it mean? That basically 5 is a factor of P square. Can we say that? Because Q is an integer, so Q square is also an integer. So if you can write P square upon 5 is equal to Q square, we can say that 5 is a factor of P square or a divisor of P square. So if 5 is dividing P square, 5 will for sure divide P as well, right? We have studied this property in this session as well. So if 5 is dividing P, can we not write P by 5 is equal to C, which is an integer, right? So can I not say that P is equal to 5C over here? Yeah, that's what I'm doing, swap. Hello Music Store. Is it clear to you? So we can write P is equal to 5C over here, where C is an integer. And P is equal to 5C, I can put over here or not, tell me. 5Q square is equal to P square, so P is equal to 5C, I can put in this thing, in this equation we can put P is equal to 5C. Now I can simplify it further, you will get Q square is equal to 5C square over here. Q square is equal to 5C square. Now again what does it mean? We can say that 5 is a factor of Q square. So 5 is a factor of Q as well. This property we have studied in this session itself, that if you are dividing a number, square of something by a prime number, right? So 5 divides Q square, so 5 is a factor of Q as well. So basically what we have got, that 5 is a factor of P as well as Q as well. But isn't this a contradiction? Because in the first place we have assumed P and Q to be co-prime numbers. So this contradiction arises due to a wrong assumption of taking root 5 to be a rational number. Hence we can say that our assumption was wrong, and hence root 5 is an irrational number. Is it clear? I hope it is clear, Swap. Is this clear, Ayush, Swap, Dinesh, Shashi? Any doubt in this thing? So that's how you can do it, right? Okay. Now what is the different type of question? The second type of question. Now in the same manner, any prime number can be taken. It can be taken, suppose it can be asked to prove root 7 to be an irrational number, to prove root 3 to be an irrational number, to prove root 2 is an irrational number. You have to do the same thing in all of these questions. I hope it is clear. You have to do the same thing in all of those questions. Now different type of question is there. The second type is, suppose it is already given to you that root 3 is irrational. It is already given in the question itself that root 3 is an irrational number. You don't have to prove root 3 to be an irrational number. Assuming that root 3 is an irrational number, you have to prove that 5 plus 7 root 3 is also irrational. You have to prove that 5 plus 7 root 3 is also irrational, assuming that root 3 is an irrational number. I hope that is clear to you, right? So over here, we can take 5 plus 7 root 3 to be a rational number. Assume 5 plus 7 root 3 to be a rational number. So it can be written as a ratio of two integers. As a ratio of two integers. See, over here, taking P and Q to be co-prime integers, they are not compulsory. You just have to assume that P and Q are integers. So where P and Q are integers, this is also done using proof by contradiction. So we are taking P and Q to be integers, and obviously Q is not equal to 0. We are assuming that 5 plus 7 root 3 is a rational number. So by the definition of rational numbers, we can write 5 plus 7 root 3 to be equal to P by Q, where P and Q are integers and Q is not equal to 0. So what we will do over here, can I basically separate out root 3 on one side of this thing? I can separate out root 3 on one side of this equation. So I can write P minus 5Q upon Q over here. So what I can do, I can take 7 on one side, I can take 7 in division on the other side. So P minus 5Q upon 7Q is there. I hope this is clear. Now you see over here, P and Q we have already assumed to be integers. P and Q we have already assumed to be integers. So this will also be an integer obviously. P minus 5Q will obviously be an integer. 7Q will obviously be an integer. Now ratio of two integers is what? And obviously denominator is not equal to 0. So integer upon integer where denominator is not 0, is not equal to 0, is a rational number only. So this is coming out to be a rational number, right? This is coming out to be a rational number. But it is already given that root 3 is an irrational. You don't have to prove it. It is already given that. So over here we have got a situation in which a rational number is coming to be equal to an irrational number. You got it? 0 upon 0 is an indeterminate form mathematics. That is not undefined. There is difference between undefined and indeterminate that can only be proved using the concepts of limits, and obviously we cannot do it over here right now. I hope it is clear. So we have got a situation in which this is a rational number and that is an irrational number, right? So obviously an irrational number and a rational number can never be equal. So this is basically a contradiction, and this contradiction arises due to a wrong assumption of taking 5 plus 7 root 3 to be a rational number. Hence we can say that 5 plus 7 root 3 is not a rational number, it is an irrational number. I hope it is clear. It is not possible mathematics, it will be out of the domain of the grade which we are catering to right now on this channel mathematics. Limits nobody will understand on this channel. I hope you can understand that. Here we can multiply 7 into 3. Not able to understand your doubt, Bimla? Here we can multiply 7 into 3. Not able to understand? Basically what you have to do, Bimla, you have to separate out the irrational number on one part. So separation you can do if you have got this equation. You have to basically find root 3 is equal to something. So that you can do. That's, I mean, you know how to solve an equation, right? I hope that is clear, Bimla. Okay. So this is the second type of question which can be asked. Now the third type of question is this, which is also asked. It is given that root 2 is irrational. Prove that root 2 plus root 11 is also irrational. It is given that root 2 is irrational. We have to prove that root 2 plus root 11 is also irrational. Please try to understand that mathematics, if other students will watch the recording, they will get severely confused. So please try to understand, we have to work according to the domain which we have chosen in this session, right? You can go on to the Infinity Learn JEE channel for that as well. Because you can see that on Infinity Learn JEE channel, everything is there. JEE advanced level things are being explained on that channel daily. So you can please subscribe to that channel as well. If you go into limits and all that, right? So it is given that root 2 is an irrational number. We have to prove that root 2 plus root 11 is also an irrational number, right? So what you will do? Again over here we have to do it by proof by contradiction. So take it to be a rational number where P and Q are integers. Over here it is not compulsory to assume them to be co-primes, where P and Q are integers and Q is not equal to 0. I hope that is clear. Root 2 plus root 11 is equal to P by Q, where P and Q are integers and Q is not equal to 0 over here. So it is already given that root 2 is an irrational number over here. Now basically you see, in this type of question we have to square on both these sides, because we want to separate out an irrational number root 2 on one side. We want to separate out an irrational number root 2 on one side of this thing. So we can take over here square on both the sides like this. So okay. So actually there is a mistake in the question. It will not be given, suppose it will not be given that root 2 is an irrational number. I hope you understand that. Basically question is of this type. If you have got square root of P plus square root of Q, where P and Q are both prime numbers. So you have to prove this to be an irrational number. So it will not be given over here that it is an irrational number. I hope you understand that. I mean, even it is given, no problem, because let us do it further. So you can square on both these sides. So we can use a plus b the whole square formula. Something like this we can do over here. So 2ab will come up, right? Something like this, and that is equal to p square upon q square, right? So basically root 2 square is 2, root 11 square is 11. So 11 plus 2 is 13. So this is 13 plus 2 into this thing we can take in this square root. So this will be square root of 22, right? And that is equal to p square upon q square over here, right? So what I can do, I can separate out this thing over here. So I can write p square upon q square minus 13. So that is equal to p square minus 13q square upon q square. I hope that is clear. P square minus 13q square upon q square over here. Now I can divide on both these sides by 2. I can divide on both these sides by 2 over here. So what will I get? I'll get root 2 over here to be equal to p square minus 13q square upon 2q square. Have you got this thing? So we have got something like this. Root 2 is equal to p square minus 13q square upon 2q square. So basically we have already assumed in this thing, don't see this one, p and q to be integers. We have already assumed to be integers. So you see the numerator over here will also be an integer. The numerator is an integer. The denominator is also a non-zero integer, right? So basically the right hand side over here is coming out to be a rational number or not. Ratio of two integers, because where denominator is not equal to 0. But you see the left hand side over here, that is root 22, not 2. The left hand side over here is root 22, and root 22 is an irrational number. See that, therefore I think there is a mistake. It is given that root 22 is irrational, right? So even if it is not given to you, root 22 is, suppose even it is not given to you, you see that square root of any non-perfect square number is an irrational number only. This is an also irrational number. Square root of any non-perfect square number is an irrational number. So you have separated out root 22 over here, and this is a rational number because it is ratio of two integers. So this is a rational number equal to an irrational number. So this is a contradiction or not? And this contradiction arises due to our wrong assumption of taking an irrational number to be a rational number. Hence, you will say that root 2 plus root 11 is an irrational number. Hello Ayush, welcome to this session. Hi Dead Official. Is it clear to every student in this session? Just confirm that in the chat, guys. So only two types of questions are asked in this proofs of irrationality basically. Hello Ayush. Hello Dead Official, am I audible and visible to you? So is this clear to every student in this session? Okay. So again I am saying, it will not be given to you that root 22 is irrational. Even if it is not given in the question, you can say that root 22 is an irrational number because it is the square root of a non-perfect square number. That's it. Obviously, that is not there even up till grade 12 mathematics. In no way we are going to discuss that on this channel. It comes in graduation only. I hope you understand that. Okay. Now, one or two, three main questions were left in the previous session on the basis of concepts of HCF and LCM and product of HCF and LCM. So, we'll do those questions. So, can you tell the answer over here? Can you try doing this and tell me the answer? If two positive integers a and b are written as this, where x and y are prime numbers, then the result obtained by dividing the product of the positive integers by LCM AB, LCM of AB. Can you tell the answer over here, guys? Okay, Dinesh, very good. Okay, Ayush. Okay, let's see dead official if it is correct or not. What about other students? So basically, where x and y are prime numbers, then the result obtained by dividing the product of the positive integers. So the product of these integers are what? X cube y square into xy cube. This is their product, yes or no? X cube y square divided by into xy cube. Now what is their LCM? It is already given that x and y are prime numbers. So their LCM will be highest exponent of x over here, highest exponent of x and highest exponent of y. So it will be y cube only, right? So basically it will come out to be, I can cancel out x cube y cube. So it will come out to be xy square. So option B is correct over here. Is it clear to every student? Option B is correct. Ayush, dead official, mathematics. Dinesh, is it clear to every student in this session? You just have to find the product of the numbers and divide the product of the numbers by their LCM. So you'll get xy square as the answer. Any doubt in the question, guys? You must have done slight mistake over there, dead official. Is it clear or not? Okay. Now let's do the next question over here. It's basically the, yeah, whatever it is, yes, that is correct, only month. So you have to do the same process in anyways, month. I hope it is correct. Yeah, the product of two numbers. See, if you have got two numbers, so product of two numbers is equal to the product of their LCM and HCF only. This we have already studied that, right? So AB, LCM of AB and HCF of AB. So I did this because anyways you have to work like that only. I mean, it will not basically save your time anyways, right? So Dinesh, I hope it is clear to you. XY square is the answer over here, right? Okay, so let's proceed to the next slide. Let's try doing this one. So basically the statement assertion is if product of two numbers is this and their HCF is this, then their LCM is this. The second is HCF is always a factor of LCM. So what is the correct answer over here out of the given options? Can you tell me? Can you tell that, guys? So basically product of two numbers is this and their HCF is this. So you have to find the LCM first, okay? So you have seen that suppose the numbers are x and y. So x into y will be the product of their LCM and HCF or not? Tell me. This we have already seen. So product of the two numbers is already given 5780. HCF is already given. We have to find the LCM. HCF is already given, that is 17. We have to find the LCM over here. So LCM is equal to 5780 upon 17. So you see this is coming out to be correct only, right? This is correct. So I can say that assertion is correct over here. You got it? Yeah, assertion is correct over here. Now reason is also correct. HCF is every time a factor of LCM. Do you remember this property, guys? HCF of two numbers is obviously every time a factor of LCM. Got it? So you see both are correct over here, but option B is the answer because reason is not the explanation of the assertion over here. Reason is not the explanation of assertion. That is correct, month. Yeah, both state assertion, reason, they are correct, but reason is not explaining the assertion over here. I hope it is clear. Any doubt in this thing, guys? HCF of numbers is always a factor of their LCM. So for example, a simple question can also be asked like this. Suppose LCM is given to be just LCM is 200, just suppose. So can the HCF be equal to suppose 23? If LCM is 200, HCF is 23, can this situation happen? Hello Anshul, welcome to this session. So you will say no, this situation cannot happen because HCF has to be a factor of LCM. You got it? HCF has to be a factor of LCM. So you can say this situation will not happen because over here 23 is not a factor of 200. So in true false it can be asked. I hope it is clear to every student in this session. Okay, so let's move on to the next one over here. The sum of two numbers is this and their HCF is 81. Then the possible number of pairs of such numbers are. Can you tell that? Can you try doing this one? If the sum of two numbers is this and their HCF is 81, then the possible number of pairs of such numbers. So see, whenever HCF is given, HCF is 81. So we can say both the numbers will be of this form. Suppose x it is, first number is x. So first number, or maybe I can write it like this. Let's not increase the number of variables. So one number I can write of the form 81x and the other number I can write of the form 81y. And we can say that x and y are co-primes. Yes or no? That's how you find HCF or not? Tell me guys. That's how you find HCF. You can assume the number to be of this form 81x, 81y. Then only you can say that their HCF is 81. If you assume x and y to be co-primes, there must be no common factor between x and y except 1. I hope it is clear. Now the sum of the numbers is given. Sum of the numbers over here. So 81x plus 81y, that is equal to 1215. Right. So from here what is x plus y guys? X plus y is 1215 divided by 81. So what is this coming out to be? You can simplify. Suppose 9 I am doing. So this is coming out to be 15. So x plus y is coming out to be 15. So basically you have to find unique co-prime pairs whose sum is 15. You got it? Unique co-prime pairs whose sum is 15 you have to find. Co-prime numbers only. So how can you think that? See, if I take 1 and 14, so can we just increase? I can write 2, 3, 4, 5, 6 over here and then 7 and 8. And I can decrease, then only sum will remain 15. Na? So I can take 13 over here, I can take 12 over here, I can take 11, I can take 10, 9, 8 and then 7. I hope that is clear. Now you have to take unique pairs only. They are not unique pairs. So I don't have to take this one. Because order does not matter over here. Na? You take 7, 8 or 8, 7. That does not mean, that does not make any change. So you have to neglect this one. Now out of these options, you have to select co-prime pairs. So you see there is no common factor between 1 and 14 except 1. There is no common factor between 2 and 13 except 1. But these are not co-primes. These are co-primes, not co-primes, not co-primes. These are co-primes. It means no common factor except 1. So how many pairs, such pairs are possible? 1, 2, 3, 4. 4 such pairs are possible. I hope it is clear. And those pairs you can write as well 1, 14 or you can write 14, 1 as well, no problem in that. 2, 13 over here. And then you can take 4, 11 over here. In this case I am talking about. And then 7, 8 over here. But the answer is not this. If you want to find the number, if you want to find such numbers, so they are 81x and 81y. You got it? They are 81x and 81y. So you can say, suppose I want the first option. So I'll get 81x, x is 1 and 81y. So 81 into 14. So this is one of the two numbers whose HCF will be 81 and whose sum will be 1215. I hope it is clear. It is from board exam only. It is a previous year question only. These questions are there in sample paper month. So see, I will not, मैं कुछ ऐसी चीजें नहीं लूंगा जो बिल्कुल तुम्हें परेशान करें. I hope you understand that. I'll not deviate you people from your path. Obviously, some 1 or 2, 3 questions I can take to be of tough level. But obviously if it is Infinity Learn class 9 and 10 YouTube channel, I will tell you that what I am explaining. It's not that I'll do anything unnecessarily, I'll explain anything of grade 12 or maybe of graduation in this session. It is not possible and it will confuse many students. I hope you understand that, okay? Yep. Okay. Now can you do one question over here? Although this type of question will not be asked in grade 10 board examination, but I am just taking this question so that you can revise the concept of irrational numbers. So for that purpose only, I am taking this question. Yes, dead official. I will explain everything which is there in your CBSE syllabus, and also I will take extra things as well in the class. Okay, but when I am taking something extra, I'll mention that properly, that this is not there in your syllabus. So you will not get confused. Okay. So over here you have to find the value of A. So what I can do, guys, if I take the left hand side over here, can I rationalize the denominator? You have studied rationalization of denominator, 3 root 2 minus 2 root 3 over here. So you see 3 root 2 minus 2 root 3. So in order to rationalize the denominator, you will multiply and divide by 3 root 2 plus 2 root 3, right? You will take plus sign over here. And why you are actually doing so? Because you want to fix it in an identity. You want to fix it in the formula. So this is 6 into 3 root 2 plus 2 root 3 divided by, this is of the form a plus b, a minus b. You see the denominator is of the form a plus b, a minus b. So it will be a square minus b square. 3 root 2 the whole square minus 2 root 3 the whole square. I hope it is clear. So this will give you what, guys? This is 6 into 3 root 2 plus 2 root 3 divided by, this is of the form a square minus b square, right? So you see 3 square is 9, root 2 square is 2, minus 2 square is 4, root 3 square is 3. So this is basically 18 minus 4 3s are 12, that is coming out to be 6 only. So this is coming out to be 6, this will be cancelled out. So this is basically equal to 3 root 2 plus 2 root 3. I hope this is clear. 3 root 2 plus 2 root 3 is coming over here. Now this thing is basically equal to what? This is 3 root 2 coming out to be 3 root 2 plus 2 root 3. I hope that is clear. If you compare on both these sides and you find the value of A, what will you get? You see this can be cancelled out over here. So you will get what over here? You will get minus A root 3, that is equal to 2 root 3 over here, correct? So you can cancel out root 3. So will I get A is equal to minus 2 over here, guys? Tell me. So A is equal to minus 2 is the answer. Minus 2 it is coming month. Yeah, that is correct. You must have done some mistake, that official. Exactly, minus 2 is the correct answer. I hope this is clear to every student in this session. Okay. So basically one question I am giving you, try doing this and you have to comment the answer in the comment section after this session. Okay. Try doing it and comment the answer in the comment section. It is a similar question. P is given to be 5 minus 2 root 6. You have to find the value of P square plus 1 by P square. And I'll explain that in the next session as well. So basically that's all we needed to discuss in this class. In the next class, we'll be starting with the next chapter and I'll discuss that question as well. You can comment the answer in the comment section after this session. And in case if there is any doubt, you can put that as well. So that's all we needed to discuss in this class. Don't forget to like, share and subscribe to the Infinity Learn class 9 and 10 YouTube channel. And also don't forget to subscribe to the Telegram channel as well. Bye bye guys. See you then in the next class. Take care everybody.